Hey there, AP Stats Cats. I have some examples today to talk about how to use the random digit table and also how to read the normal probability tables. Now, we haven't really focused on the normal probability table so much this year because we have always just counted on normal CDF and inverse norm, which you will have access to on the AP exam. There is no reason you should not be able to use those tables. But I thought that in case you were curious, I would fold that into this lesson as well. So let's take a look at number one. It says, imagine that weights of party-sized bags of Cheetos are normally distributed with mean of 15 ounces and standard deviation of 0.39 ounces. Alex, my son, really likes his Cheetos. So the question is, what is the probability that the next party-sized bag I bring home for him, randomly selected, of course, weighs more than 15.4 ounces. Calculate this answer as you usually would, and then stay tuned for a lesson as to how to calculate it using the normal probability table in your formula tables and packet. So take a few moments now, do the work that you think you need to be able to find this probability. Just do it like you usually would, and then we can compare answers, and I will give you a little more information about what to do with that formula packet. All right, are you ready to check answers? If not, go ahead and press pause and finish up your work because, spoiler alert, I'm about to show you my answers. So here we go. I got 0.1525 as the final probability. That was based on a z-score of 1.026. Notice I did include a graph over on the right-hand side. If you are typing your answers, you will not be expected to draw a graph. If you're handwriting your answers, it's always a good idea to add that in as a little bit of extra flair and overall understanding. But clearly, if someone is going to be typing and they can't be expected to have it, then certainly you wouldn't be expected to have it. But it does show that you really do know what you're talking about if you can bring in a diagram as well. All right, if you're not sure quite how to go from the Z to the P, go ahead and take a look on your calculator. You would go into second vars. And then, whoops, sorry, that didn't work. Let's try that again. Second vars, normal CDF. We're going from our lower end of the shaded region, 1.026, up to the upper end, which is something big like 100 or 1,000. Notice I am using z-scores, so I'm going to keep the mean and standard deviation as the standard normal numbers, 0 and 1. So that will give us 0.1524 actually. So I don't know why I said 0.1525, but it's close enough. It's all fine. So that would be your final answer as far as normal CDF is concerned. If you wanted to be able to figure out how to do this on a table, that's something that we have not had to do this year, and you should not be expected to do for the AP exam either. But I felt like, well, hey, you know what? Maybe you're curious. What would you do with the table? So if you go ahead and take a look at page 3 of your table, you'll notice it says Table A, Standard Normal Probabilities. If we go ahead and scroll down, you'll notice that there are negative values of Z all the way through. So this goes all the way from negative 3.4 down to negative 0.0. Well, our Z value is positive, so that doesn't help. Go to the next page. Now you'll see underneath where it says Table A, it has the z-scores going from 0.0 all the way to 3.4. Well, in our example, we had Z, oops, sorry about that, Z is 1.026. Well, we're going to go ahead and take a look at the tenths place over here in this bar column, and then the hundredths place up here based on the different column headers that we have a choice of. So we're really going to look at 1.03. So 1.0 is going to be this row right here. Then this would be 1.00, 1.01, 1.02, 1.03. So what we're looking at is a p-value of 0.8485. Now that's not what we got in the calculator, but go back up here and take a look at what we have in the diagram. Oh, this is saying that the table entry for Z is the probability lying below Z. So if this Z here is at 1.026, the 0.8485 that they're talking about is the area left of that boundary. So what's over here, which is what we're actually interested in our question, it would be 1 minus 0.8485, otherwise known as 0.15 Nope. 0.1515. Okay. Oh, I know why. Sorry, I was going to say it's supposed to be 0.1525. The reason why they say it's 0.1515 is because we didn't actually look at 1.026. We looked at 1.03 because the table is only accurate to hundredths place. If we were actually looking at the probability based on a z-score of 1.026, we get a slightly more accurate answer, and so your calculator is actually going to give you a more accurate answer than the table. But in case you were wondering, that's how you can figure it out. If you really don't care and you say, but my calculator is going to be right there the whole time, you're right. And I would say that most times in real life, people don't use the tables anymore. They just use technology. But I just wanted to give you that opportunity. So hopefully that takes care of question number 1. Let's go ahead and see what happens in question number 2. In question number 2, we are asked to round our answer from number 1 to the nearest hundredth. So 0.1515, 0.1524, 0.1525, no matter which of those three ended up, you would still round to 0.15 as your nearest hundredth. There have been some questions recently about some of the different examples that we've had, where sometimes we're looking for 2-digit numbers and sometimes we're looking for 1-digit numbers. The reason why that changes is all based on the probability itself. In this case, we're looking at p equals 0.15, which is a 15%. It's awfully difficult to assign digits where 15% of them represent a win when we're only working with single-digit numbers. I mean, how many digits would be 15% of 10? That would be 1.5. We can't do that. We have to have a whole number of numbers representing in each category. So that's why in this particular case, we would have to have 2-digit numbers, because we could take 15% of 100 options and that would make sense. Now, how you set this up is up to you. Really, you can design it so that any 15 out of 100 numbers represents a win, which in this case would be the party size bags that weigh more than 15.4 ounces. Oops, did I really say 15.6? I meant 15.4. Sorry, guys. Let's fix that. I was not trying to be sneaky there. So it doesn't matter how you set it up. You could say, for example, that if I'm going to go from 00 to 99, that the first 15 numbers represent a win. So you could say that 00 to 14 represent Cheetos bags weighing more than 15.4 ounces. And then 15 through 99 would represent Cheetos bags weighing less than or equal to that much. Now, that's not the only way to do it. You could also say 00 to 84 represents Cheetos bags weighing less than or equal to 15.4 ounces, and the rest of them, so 85 up to 99, represent the Cheetos bags weighing greater than 15.4 ounces. That would be fine too. It really is up to you, as long as 15 out of 100 represent the yes and the other 85 represent the no. Notice I did start with 00. The reason for that is because if I had started with 01, I would have to go all the way up to 100, and every time I'd search for numbers, I would have to go in groups of 3. I'd have to look for 3-digit numbers, and that's even more of a pain than 2. So I would start it this way, and then take a look at these numbers 2 at a time. So the first 2-digit number I come up with is 19. 19 is in the second category, so that is not a Cheetos bag that I want. Then I would look at number 28, still no. Then 37, still no. Then 36, still no. Why? Because all of those numbers are in the 15 to 99 range. Then finally, here we go. We got it. We came up with 12. And 12 is what we want because it is in the group from 00 to 14. Go ahead and pause the video and see if you can figure out how far you have to go down the line to be able to get 4 bags of Cheetos that you want because they have the right size. All right, so what I came out with was 17. It took 17 bags in our simulation to find 4 bags of Cheetos of the size that we want, which was 15.4 ounces. So again, I put lines down every time I came to 2 digits, and then I circled where I had any of the numbers that were in the right region. So that would be, again, anything from 0, 0 to 14, because that's how I set this up. Notice what I did is I started out by saying use P, sorry, my face is in the way. Let's see if I can move that. Okay, there we go. So use P is approximately 0.15, just so that they saw what I was doing in case maybe I rounded wrong or something. I want them to know what I'm thinking. I want to be able to communicate. And then I said, let 0, 0 to 14 represent the Cheetos bag weighing more than 15.4 ounces, and then the rest, 15 to 99, represent the Cheetos bag weighing less than or equal to 15.4 ounces. So I got that set up, all taken care of. Then I'm just going to draw right on here. For those of you who are planning to print out your questions, you can do that. That is allowed. For those of you who do not have access to a printer or do not choose to, I would just copy down these numbers onto your page, whatever you're doing, whether it's typing or handwriting, and then you can highlight or you can circle or you can underline or whatever. Tell the reader what you're doing. Make it super clear, because this isn't super complicated. But if you just circle a whole bunch of numbers and don't say why or don't have some sort of label, they're not necessarily going to know what's going on. So then I explained here, using the table of random digits, look for 2-digit numbers where, again, 0, 0 through 14 represent the bags of Cheetos we are looking for. Keep looking until we encounter 4 numbers in that range to signify 4 bags of party-sized Cheetos weighing greater than 15.4 ounces. Context, anyone? Sure enough, you got to put it in there. And then in our simulation, took 17 bags of Cheetos to find 4 of the desired sizes. All right, some of the examples that we've done, though, we're not looking for 2 digits, and that's because of how we're rounding our probability. In number 3, it says, explain how our process would change if you were supposed to round your answer in number 1 to the nearest 10th instead of the nearest 100th. Well, if I take 0.1525 and I round it, that becomes 0.2. So that just means 2/10 of all the numbers that we have need to represent yes, this Cheetos bag weighs more than 15.4 ounces, and then the rest of them represent no. I happen to choose 2/10 being 0s and 1s were the ones that we were looking for, and then 2 through 9 would represent the others. I could have said 5 and 7 were the ones that we were looking for, and all the rest were no's. It's totally up to you, whatever makes more sense and is easy enough to deal with. In this case, it was kind of weird because I also encountered 17 bags. That's just kind of a fluke. It doesn't have to be that way. I also didn't draw my lines here on the chart because I was only looking at 1 digit at a time. So I didn't think that it was as necessary. You certainly could, but you might also end up crossing out the numbers. I would say if you're looking for digits, or rather numbers that are more than 1 digit long, it would be a good idea to keep kind of slicing between them on the table. But if it's just 1 at a time, that's okay. And look, what did I do? I underlined and circled the ones that I wanted. And then I explained in the simulation where the probability was rounded to nearest 10th, it also took 17 bags of Cheetos to find 4 bags that weigh more than 15.4 ounces. Again, I put in the context. That is because we needed to look at 17 single-digit numbers in the random digit table. Sorry, this cut off. To find 4 digits that were 0s or 1s. I'm going to pause and write that in. All right, so there we go. So again, I explained the process, I explained my logic, how I set up the numbers, etc. But I just want to make sure that you know the difference of when do you need to look for 2 or more digits on a random digit table, and when do you just need to look for 1. Keep it simple. If you can just look for 1 digit at a time, that's going to be a little bit of a time saver and a little less complicated, but don't be afraid to write right on that random digit table. All right, the other thing I wanted to point out is a calculator reminder. So if you go back to your calculator and go to the mode button, some of your modes are going to look different than others. But notice that down here on the bottom, almost to the end, it says Stat Diagnostics and Stat Wizards. You want to make sure that both of those are on. So again, this is the mode button, which is right next to the second key. Turn on Stat Diagnostics, so you can go ahead and scroll down, and then over to on for the Stat Diagnostics and on for the Wizards. That's what allows you to have things like R and R squared show up when you do your linear regression. I hope that that helps. If you have any questions, please let me know. Have a great day. Take care.